On 7.1, solving systems by graphing. First thing we're talking about today is system of linear equations. And with a system of linear equations, it's when two or more equations together and you're looking for a solution. So remember, linear is a straight line. So you have two or more equations that make a straight line, and we are going to be looking at where they intersect to solve equations. Okay, so here's our first system of equations, and the system here is y equals 2x plus 1 and y equals 3x minus 1. So this is a system of equations because it's two linear lines that are going to hopefully intersect and give us our solution. So take a look. Our first equation, using the information that we got from last chapter, y equals 2x plus 1. We know m is going to equal 2, and my y-intercept equals 1. So we could graph this just based on this information here. So let's take a look at our next equation, 3x minus 1. M for this one is going to equal 3, and my y-intercept equals a negative 1. So take that info and let's graph them. We have a red line here, and that is crossing at 1, our positive 1. So we're looking at this piece right here. Our next one is rise 2 over 1. So this red line here is this equation. Now my blue line is crossing here at negative 1 is my y-intercept, and my slope is 3, so we're going to rise 3 over 1, rise 3 over 1, rise 3 over 1. So what's important here is finding where these 2 points cross, where they intersect. So where they intersect here is going to be the solution to your equation. So I have a point here at 2, 5 that we are telling is the solution to this equation. So we graph both equations on the same coordinate plane, and we found where they intersect. And the lines here was at 2 and 5. So 2, 5 is the solution. So we can actually check and make sure that this is true for both. So you can see here, my y, this is my x, this is my y. I plugged in 5 for y and plugged in 2 for x. 2 times 2 is 4, plus 1 is 5. Does 5 equal 5? Yes, that checks. Over here, plug 5 in for y, 2 in for x. 5 did equal 5, so these are solutions. I'll let you go ahead and read this. So, which system of equation models the cost as a function of the class? Here, non-members pay $4 per class, while members pay $10 plus an additional $2 per class. So let's kind of go through here. If A was the number of class, C was the total cost of the class. So let's go through. We have an additional membership fee of $10 plus 2 times however many classes we attend. Where a non-member, the cost is going to be $4 per class they attend. So this is what we should be looking for, which would have been, I think, A. Here's our next example. The system below models the cost of taking aerobic classes. Find the solution. So at what point are you better off to pay the membership fee of $10, or at what point are you better to just pay per class that you attend? So we can graph each one. So we take, this is our 2 equations we just created from our last info, and we found slope is 2, intercept is 10, and here we have a slope of 4. However, my intercept is going to be at plus 0. So once we graph, we can see here we've graphed at 10, rise 4 over 1, rise 4 over 1, rise 4 over 1, creating this line right here. We can look at this one. y-intercept at 4, and we are at 0. Slope of 4, up 4 over 1, 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 up 4 over 1. We have an intersect at 520. So, at 520, what is that referring to? So when x is 5 and y is 20, you're paying the same amount. So, after 5 classes, because we had 520, after 5 classes, number of classes, it will cost you the same, and it will cost you $20. So total cost $20 after 5. So it goes into that. It doesn't. Before here, it's cheaper for your total cost to pay just per class. But as soon as you attend 5 classes, you're going to pay the same amount. If you would attend 6 classes, it's now cheaper, 6, 7, 8, it's now cheaper to pay the $10 membership fee instead of paying per class. So that's kind of interpreting what that info is saying. Here we're going to solve by graphing. So, graph both on the same thing. We know m here, our slope here is going to be 3, y-intercept is at 2. Here, slope is 3, y-intercept is at -2. So we're going to graph these on the same plane. What do you notice about this red and blue line? Do they intersect here on this graph? No, they do not. So since these do not intersect, these lines are parallel, they're never going to cross, there is no solution. Okay? So there's actually 3 different, when you're solving a system equation, there's 3 different answers. There's a no solution because the lines are parallel. There is, which is our example here, there's the previous example where they intersect at a point, and that's a solution, so there's one solution. And then we're going to talk about the next one here. Graph these on the same line. Notice this is in our y equals mx plus b form, but we do know the y-intercept once you solve this. So what you would do here, 3x plus 4y equals 12. Subtract 3x, 4y equals negative 3x plus 12. Divide by 4. So y equals negative 3/4 x plus 3. So you could solve it, graph it this way, or what they're saying here is they plugged in 0 for each of these here. So when x was 0, y would be 3. And when y was 0, x equaled 4. So they're saying the x-intercept is 4, y-intercept is 3. My next equation, same concept as what we just talked about here, is this next line. So our graph was at 0, 3, and 4, 0. And they made our line. So the graphs are on the same line. So we took this here and put it into y equals mx plus b form, which is over here. Okay? And then it actually ends up being the same line as you can see here. So the reason they took this and found the intercepts using this method down here is so you wouldn't actually completely see that these are the same lines. Okay? They are the same lines, so this is our third possible way, would be if your 2 equations in your system form the same line, there's many solutions, because right on top of this red line, okay, is actually another line, and you can tell that they are intersecting. There's points at every single along this line. Okay? So that means there's infinitely many solutions because they're all crossing at that point. Alright. Alright, I think you guys are ready for your assignment. Okay, the last thing here is, this is a summary that's in your book. For reference, it is on page 376. You can take a look here again. So if they have different slopes, and different, and when you graph them, they intersect here at a point. Okay, this point right here is the solution. So there would be one solution. Where here, when you graph them, they are parallel. So they do have the same slope, but they have different y-intercepts. Here's one here, here's the other. They are parallel, so there is no solutions. Where our last possible solution for when you solve these system of linear equations would be same slope, same y-intercept. They are the same line. So because the lines are the same, there's infinitely many solutions. So that's kind of a recap of today's lesson. So when you solve a system of equations, first of all, you graph both equations and you see if, first of all, do they intersect? If they do, that point is the solution. If they do not intersect, are they parallel lines? If they are parallel, there's no solution. If they are the same exact line, then there's infinitely many solutions. Go ahead and start your assignment.